Again, and it's time for Catalog and Cocktails, presented by Data.World. It's your honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd, product guy, customer guy at Data.World, joined by co host Juan Cicada.
Hey, Tim. I'm Juan Cicada, the principal scientist at Data.World. And as always, it's a pleasure to hang out Wednesday, middle of the week, end of the day. I'm on the East Coast, so it is 5 o'clock today for me. And today, I'm super excited to go into one of the topics that is now very dear to my heart, and not just knowledge graphs, but it's like all the mix of all the stuff that is so hot right now when it comes to AI and vector databases and RAG and all that stuff. We're going to go talk about this stuff. Super excited to have Mike Dillinger today, who's an author, a speaker, a well-renowned scientist, former AI research scientist at Intel Labs, the former technical lead at Knowledge Graphs at LinkedIn, as well as at eBay. He has an extensive career in anything on all things around language, these linguistic machine translations. Mike, it is such a pleasure to have you here. How are you doing?
Thanks, Juan. Great. I appreciate the introduction. I'm doing okay.
Fantastic. Let's kick it off. So what are we drinking and what are we toasting for today?
I'm drinking coffee, always coffee. And I'm toasting the increase of interest in knowledge graphs. Because all knowledge graphs come and go, and now people are interested. That's what I'm toasting.
I'm very excited about that too. I mean, people all know me. This is stuff I've been working on for my entire career, which is like just 15 years, right? But it's still everything I've dedicated. And folks like you, Mike, probably twice as that. So I'm really excited. So I'm going to cheers to that. For I think generative AI has brought the time that his knowledge graphs are coming up, and it's stuff that we've been working on for decades and decades. So, and I'm drinking a Moscow Mule today. I'm actually at a hotel, and I saw the fancy cup, and I'm like, hey, I haven't had one of those in a while. So how about you, Tim?
By the way, I love those copper mugs. That's always fun. I have a couple at home that I enjoy using. I'm drinking a cocktail that's very similar to a Negroni right now. But it's a thing called San Bitter instead of Campari, and it comes in one of these little tiny glass things here. So it's San Bitter with some gin and some orange liqueur, and tastes pretty good. I have a little lemon peel in here as well. And I'll also cheers to knowledge graphs. I have not been spending not nearly as long, Juan and Mike, as you have both been around knowledge graphs, but I've been in the data and AI space for a very long time, and knowledge graph certainly seems like a very important missing piece to the overall puzzle, especially as generative AI is coming to the fore here. And so cheers. Looking forward to the conversation today.
All right. Cheers.
Cheers.
So our warm-up question today. So we're going to get pretty nerdy talking about generative AI, vector databases, knowledge graphs, and so forth. So what's an example of a nerdy hobby or interest of yours that is not work-related, or some nerdy pastime?
Nerdy pastime for me is knowledge graphs. It's not work-related, but it's work-related. So when I'm not working, I'm still thinking about knowledge graphs. Put it that way.
Doesn't matter. Work, not work. Knowledge graphs.
Yeah, that boundary is really kind of tenuous, let's say, in my case.
Yeah, well, that's always fun when you're like your work is your hobby, and your hobby is your work. Like that's hopefully something you can always strive to have. So
yeah, it's a passion, I think you'd call it.
It's a passion. Yeah. Tim, what is your nerdy pastime?
I would say, even though there's a few nerdy things going on in my life, it's probably video games, because even though I don't play video games as nearly as much as I used to in the past, my wife and I often enjoy, after the kids finally go to bed, I can pull up like Assassin's Creed or something like that on the computer or on the PlayStation. We play that together, and it's a lot of fun. And for those that are not watching, who are only listening, Mike has a really interesting map as his background, and so I always find that like history and things like that are very interesting. And so anytime a video game has something to do with history, I find that more interesting than not. So. What about you, Juan? You got any interesting nerdy pastimes?
So following with the map, as people know, I travel a lot. So I like to keep track of all my flights, and I've been keeping track of them for years now. So, and then I use there's all these different apps, and then I can go create the maps, and you can see all the legs and where I've been, and I just keep track of.
I used to have a really good app for that, but I think it disappeared. What do you
Yeah,
use?
there's a couple of I mean I forget the name of it now, but I just keep track of the raw data myself. I have
You still check in quite a bit, right, Juan?
Yeah, and I do. There's another nerdy thing. I use an app called Swarm. So wherever I go, I check in. This was from the era of Gowalla and Foursquare and stuff, like over 10 years ago. So, and also a shout out to a former podcast guest, Dan Bennett. Dan also and I, we always check in, so we always know where we are, and then we've actually bumped into each other. It's like, hey, I'm here too. So, or oh, I was there last week or something. So I like to keep track of where I am, and it's part of a history, right? You start building your history. So, history,
Right.
travel, I like that nerdy. But all right, let's kick it off.
Travel
So,
is good.
Mike, no, honest, no BS. Like, what's on your mind with all this generative AI and knowledge graph? You're saying that this is what you think about all the time. So, tell us more. Let's dive in. What's going through your
Yeah,
head?
there are a lot of things on my mind. So one of them we might talk about is, LLMs and knowledge graphs. And I think people don't have a really clear idea of how they're different and which ones are good for what. The way I like to phrase it is knowledge graphs are good for reasoning and for concepts and for coherence, and language models are good for language, which makes great sense. But I see people kind of mixing them up indiscriminately and saying, oh, okay, we just use knowledge graphs as text input for our language models. And then we have things that are really different entities, concepts and strings. And that makes things more confusing. So one of the things I'm working on is trying to separate them out, at least in my mind, and then explain to others how I do it.
So you use the word reasoning and the words reasoning and coherence when you mentioned LLMs. I'm sorry, knowledge graphs. And I think sometimes people, when they use LLMs, they feel like
about reasoning. Yes,
it feels like there's coherence and reasoning here. Can you unpack that a little bit more?
Yeah, that's really good. I think that's a key issue that we face at the moment. So this is why I'm trying to separate things out more clearly, at least for myself. Usually, so I'm trained as a cognitive scientist, and in cognitive science, we make a pretty clear distinction between language and reasoning, right? Language and cognition. Some of the generative AI models aren't doing that very well. So then they mix things up. The key question that I like to ask when we talk about this is, you have an LLM, sure, it looks like there's reasoning, it looks like there are concepts involved, but where are the concepts? Do the algorithms have access to the concepts, or only the users have access to the concepts? So for LLMs, like ChatGPT version 2, for example, where there's only string input, they're just trained on strings and more strings, then it's hard to say that there are any concepts involved. And the whole question of meaning in the middle of this and reasoning and concepts becomes, as we've all seen, something contentious. Okay, so now it's coming in again through the back door because everybody knows we need it through knowledge graphs.
So from a practical perspective, and I'm seeing this argument now about from LLMs, do they actually know and stuff? Aren't we kind of coming up with a new definition of what knowing or intelligence means? Because
I don't think so.
Okay.
I think we have the illusion of intelligence when we train LLMs only with text, because for us it's automatic and effortless to interpret what the LLMs produce. Okay, but now we see with the multimodal LLMs that they work really well associating strings with pixels, for example, and parts of images, or notes and parts of music. So the multimodal ones have what's normally considered meaning involved. You have a string that's associated with something that's not a string, like a swatch of pixels, for example. So in that sense, we get a lot closer to what we usually call understanding and reasoning.
So I think there's also, when it comes to knowledge graphs and large language models, I think there's like this two-way interactions, right? It's like, how do I use large language models to help kind of create the knowledge graphs, but also the other way
Right.
around is, how does the knowledge, use knowledge graphs as kind of inputs to improve the large language models, and
Exactly.
then at the end they're like all mixed. So it's like technically like three different approaches. So you can see that I see it, and I'm looking. I see a question, or kind of question comment comes up here. Is like, I'm curious about how is to create knowledge graphs from semantic layer concepts. Um, I'm just looking at that comment right now. I'm just thinking about knowledge graphs and large language models from one direction to the other. How are you seeing this?
So you talked about the sandwich model, where you have LLMs for input, you have knowledge graphs, and then you have LLMs for output. So there's these feedback loops kind of things.
Okay.
I don't think that mixes things up. I think it behooves us to separate them more carefully so we can manage them better. I'm not clear about the question about creating knowledge graphs from semantic layer concepts. Knowledge graphs are the semantic layer, right? So it's not clear to me how we're doing it. How can we create them from text is a really interesting area of research.
Mm-hmm.
Okay, so we have raw strings. We don't really know what they mean, but can we extract from there something that's similar to a concept and maybe validate it? Yes, we can. And an intermediate step there is doing things like exploiting dictionaries and glossaries, where the text is focused on, well, what are the components of meaning for this term? Okay, so that's a half a step. That's more than half of the way there from those who are just saying, you write stuff about something and we try to pick up the meaning, the concepts from there. So that's a really interesting area of research. We know that LLMs can do some of that pretty well, but I'm missing documentation. I would like to see more documentation on which kinds of concepts and conceptual relations LLMs are good at extracting and which ones they're not.
Mm. Well, I know one other area of technology that seems to really be trying to address the whole, let me extract some kind of either meaning or association from text, is around the use of vector databases. Do you see that as a very useful and interesting tool in this area? And are there any sort of pros and cons to vector databases around this?
Sure. So the key question that I have to ask when I think about, as myself, when I think about vector databases is, what are we putting into the database? A lot of times what we put into a vector database is just a lot of strings. And then we see, this string shows up with that string. Okay, this is standard language modeling kind of information. These are used in very similar concepts. But that breaks down a bit because you have things like wine and cheese are used in the same context. They show up together, but that doesn't mean they're the same food group. Right? And doctors and nurses, they show up in lots of similar contexts, right? They're closely related, but it doesn't mean that a doctor and a nurse, it doesn't mean they're synonyms. Okay, so there are these inherent limitations when we rely only on strings. And this is what Han, I think, was saying a minute ago. When we bring in knowledge graphs, then we start to have available resources, the resources that we need to kind of distinguish between these things. We have additional features that we can rely on, not just co-occurrence of strings, raw strings.
So one of the things that I'm seeing right now, kind of just through the excitement and the hype, is that I think it's easier right now to start kind of kicking off things with unstructured, with text, because it's just kind of, it's out there easier. So coming up with the chat application that takes in text and you put embeddings and you put in the vector database, like that's all tutorials come with this. You can do this in a couple of hours, not minutes, right? To basically do it. So that's what people are getting really excited about it. But then you start, then when things don't work that well, then it's like, oh, we have to figure out how to do the chunking and how to separate the stuff. And it ends up like, in a way, like some weird form of like ETLing that is not really well defined and repeatable, and it's frankly ad hoc in a way. But curious to know, like, what's your perspective about this, and how is this going to evolve? And then to kind of connect this all together is, how are we going to see vector databases and knowledge graphs come together? Is this are they separate things that they have their own standalone and they complement each other? Is one going to be embedded in the other? Like, anyways, I just brought up a bunch of stuff, but
yeah, you did. I'm going to say, hold on there, Juan. We got 1,000 things to talk about at once. Where do you want to start? So the ETLing kind of thing. Okay, I think I lost track of your question there for that one.
No, so let's
vector data.
I think, ad hoc. How? I mean, people are just getting started with this, but is this combining vector databases with knowledge graphs, and I think this whole approach called RAG and stuff? How is it ad hoc, or is this something now kind of well defined, well architected? I'm curious to get your thoughts on that.
Okay, so there are two pieces there. One is, what's the relationship between the knowledge graph and the vector database? And vector database are very much like graph neural networks. They're a recoding or re-indexing of the same information from the knowledge graph. Okay, that makes it much more efficient and flexible to access the knowledge that was in the original knowledge graph. So I call that, it's a re-indexing. It's the same information in a different format. So I don't think of them as different sources of knowledge, the same source of knowledge, but in different formats. Cool. So that's one thing.
That's an important takeaway right there. It's just a different form of it, right? So
it's basically organizing the information in a way that allows it to be highly performant for that particular use case.
Exactly. Yeah. Okay. And we see the same thing with graph neural networks. What you get in is like a knowledge graph. Okay. But then you recast it as a neural network, which makes it much easier to identify and exploit a wider range of relations between the items that are in the knowledge graph. Okay, so these are reformatting, both of these, both are vector databases and graph neural networks are ways of reformatting what's already in the knowledge graph. Okay, so how does this help us with RAGs? Well, RAGs, there you go. You have these sources of information in different formats, and you basically, the way I understand RAGs is you look for the answer to the question, and you add it to the question before you ask it. So that's why I think that's why it feels kind of ad hoc to you.
Can you let's expand more for folks who are just listening for the first time or hearing this RAG? Can you expand what RAG means? Retrieval Augmented Generation. Can you explain more kind of what that process is?
Sure. Retrieval Augmented Generation is like this. You put in your query, okay, and then in the background, you have software that goes to a database or a set of documents or a knowledge graph and pulls out the stuff that seems most relevant for that query. And that gets put into as part of the prompt that's sent to the LLM. Okay, so we're enriching the prompt. It's part of a prompt enrichment strategy. Instead of just asking a simple question, we ask a question and then we add additional information, like what do we want the response to look like? And where are the best things to think of when we're formulating a response? So this is part of what's called the context. There's a context field that you can add to a prompt. And we get that from RAGs, put information from databases, knowledge graphs, or sets of documents into that field of the prompt before we give it to the LLM itself. Does that make sense?
Yes, it does. I appreciate this very clear explanation here. So then thinking about, because when you hear RAG right now, and you look at all the posts and people talking about it, RAGs are always connected with like vector databases, and I'm now starting to see more a differentiator of RAG with vector databases and RAG with knowledge graphs, and it kind of seems it's like in a way one or the other, but I think it should they come together. Or so, how are you seeing this right now?
Yep. So of course it's confusing because people are trying to figure it out. Again, the vector database is where you store the information that can come from a knowledge graph, that can come from a SQL database. You can reindex that as well, or from a collection of documents. So it turns out that if you put them in a vector database, then you have something more compact and easier to process to put into the prompt. So to reformat, again, we're back to another kind of reformatting question.
So then the question here is, how does this all come together? This is what I like to go brainstorm, is putting all these pieces together. Like, first of all, what are the minimal things that you need to start with? And how would this start expanding, and how do you know what comes next? Because everybody's just, frankly, on throwing shit at the wall and see what sticks, which is fine, right? We're just starting here. And that's why I think my earlier comment of, oh, this is seems ad hoc. And I think everything starts ad hoc until we figure it out, right? So I'm just curious, let's brainstorm here. Like, how would we start? What are the minimal things? And then keep expanding from there.
All right. So I totally agree with you. And the question of what do we need is really interesting. It's going to depend a lot on the task. So let's say your task is you want a chatbot who can answer questions about your company's offerings. Have you seen a chatbot like that before, Juan?
I have.
What do you need? You need information about what the company's offerings are. And you can do that. You can make that available in a range of different formats. You can structure it as a knowledge graph. You can dump in a collection of documents. You can do a whole bunch of things like that. Adding a vector database on top of that is an efficiency step. I don't think it adds additional information quite yet. Okay?
Mm-hmm.
But that's cool. So these are the minimal things. The other super important component is the LLM. So we have the mechanisms to both consume natural language and to produce it when we're giving a response. So the LLM plays a super important role there as the API, as it were. API for humans. Natural language in, natural language out.
I love that. The LLM serves like an API for humans.
Yeah. That's what we're talking about.
That's another quote for a t-shirt.
Thank you. Let's do that.
It's bolded in the notes.
I like that.
Yeah, no, but the API doesn't do the reasoning work. Right? We have to feed the API with relevant information and accurate information. Okay, and the best way we know to do that now is with knowledge graphs. Right?
Mm-hmm.
So one of the advantages of knowledge graphs over a vast collection of documents, it's possible to do it with collections of documents like we already do. But then we face the problem that the same fact will show up in 20,000 different ways, and that adds a lot of variability, and it makes the system more error prone. And we'll also see contradictory information, and then the system has to figure out which one is correct, which one is not, which one is appropriate for this context or for that context. So you imagine if you're doing, a support site, and you have information about this version of your product and the last version of the product, and you save in a different way this time, right? How the hell is the system ever going to decide which one is which? Unless there's additional, probably structured information about which version we're talking about and which version we have to focus on.
So, in general, I'm gonna kind of regurgitate what I think I'm concluding a little bit here, and I'm curious, Mike, if you think this resonates or not. It seems like there's sort of a pattern that these applications are all falling into, and there's a lot of it depending on your use case, but there's sort of more of the pre-processing steps, which are, make sure you're providing all the context needed for the particular thing you're trying to generate. And that might come from documents. It might come from databases. It could come from a knowledge graph. And we'll probably come back to that in a second, right? You're passing that to the LLM, which is sort of your API for humans, right? It's taking that input and then it's providing output back. And then I do know, even though we haven't talked about it a lot, there's often, going to be post-processing, testing validation that like, hey, is this not a completely, incorrect or improperly formed response that we're going to provide back here, depending on the use case, right? How accurate you need to be there. You might do performance optimizations, things like vector databases and things like that, which are going to provide you ways to do this in a better, faster, smarter kind of way. But essentially, this is kind of the pattern. And then technology is going to help you augment that. And then maybe I'll go one step further, and then I'll let you kind of react to this, which is that as you're starting to do this for lots of different use cases, and you want to represent the knowledge for your organization, is that when especially you start to get into the realm of like, yeah, you could do the retrieval augmented generation with databases and other types of things, but as you really start to do this at scale, is that when the knowledge graph especially becomes more important? Or is it more important regardless?
Yeah, I would say it's more important regardless. So let me see if we can back up a second.
Sure, yeah.
What you're focusing on was preparing a prompt for the LLM. Okay, so then the question is, why are we doing that? Why are we using RAG in the first place? Okay, we're using RAG because we're building on a foundational model. And foundational models are horrible to build, and they're very expensive. Right? So we're looking at affordances, like the design people like to say, for controlling it, for driving it this way. I call it drivable AI, for making it go this way, go that way, or adapt to this setting or to that domain. Okay? So that's one of the use cases for knowledge graphs, is doing this kind of after the fact. Let's see if we can get what we want from what's in there. But that makes a really big assumption, and that assumes that the correct and relevant information is already in the large language model. And that's kind of dangerous, okay? So we need to look for additional ways beyond RAGs to make the original model better, right? We need practical ways for doing that, so that we can rely less on RAGs. Yeah.
Now, okay, so another topic to add to this is the whole fine tuning and training, right?
Yep.
Okay.
Exactly.
So again, part on this. Let's brainstorm this architecture here. Like, so when do you decide? So let me step back for a second. And I love how you presented this very clearly. Why are we using RAG is because we're using a foundational model that doesn't have that context. We're using RAG to bring in that context, the affordance to control it, that drivable AI. But then you could also argue, well, that's why we should fine tune. That's why should we train, right? So,
and the only reason we don't train, and the reason we usually don't fine tune, is because they require much more in terms of engineering resources and computational resources. Right? Like you said, a couple of minutes ago, it'd take an hour to set up a system where you can just pour new content into a resource that a RAG can exploit. Okay, but that won't get over the fundamental limitations of the gaps in the original, right? Because we don't know what those gaps are. We don't understand them very well. Okay, so it seems like you said a couple of minutes ago that it's ad hoc. It seems like a Band-Aid. Rather than fix the underlying model and making sure that that's way better, or finding faster and cheaper and better ways of doing that, we kind of put a Band-Aid afterwards and see how well that will work.
There's trade-offs here.
Yeah, significant trade-offs.
And
right, you're not going to get a mom and pop shop to go and retrain Llama for their website.
Mm-hmm.
It's just not practical. I mean, you're not even going to get that from a mid-tier company.
Yeah.
So the solution is always going to be putting that Band-Aid on.
For the moment, we have the best solution we have is a Band-Aid. And after the fact kind of thing to say, well, just in case it's not in there, let me give you the answer.
The Band-Aid analogy is interesting. I wonder if I want to try on a slightly different analogy, and I'm curious if it works or not, which is that, when you're hiring somebody to do a job, right, you could hire somebody and say, I'm going to train you how to be the world's best computer scientist, right? And pour the time and the money and the energy into doing that, right? And sending you to
Right.
school and bringing you back and, hey, what did you learn? Are you ready, right? Like that's obviously an approach you can take, and eventually you'll get the best computer scientist. Or depending on the task, you could take somebody who is maybe more of a typical person off the street and say, hey, I want you to follow these instructions. Here's the boundaries on which I'd like you to do your job. And, assuming that is an intelligent, individual, they might be able to do a really good job for a lot less money, time, and effort. Is that kind of a little bit of analogy we can use here?
That's very interesting. That's a nicely done analogy.
Okay.
And doesn't include Band-Aids.
Right. It doesn't include a Band-Aid, right?
Well, it turns
one of the things, though, is the person off the street, you have to tailor the tasks to that person's abilities.
Mm-hmm.
Right? Until such a time as you can improve the foundational model. Okay, so I just read something this week about a really cool knowledge graph for chemistry, where they put in all the information from the periodic table, functional groups, toxicity data, and all these kinds of things. And it does a really good job of saying, here's a molecule, it's toxic. Okay, ChatGPT can't do that very well. Now the question is, should we focus on Band-Aids, or could we go and develop more tools for incorporating a diverse array of knowledge graphs on different topics?
So I want to follow on the analogy that Tim is presenting here. Like, okay, we can get a person off the street and you give them well-defined instructions and boundaries, and they can go do this without having to go invest so much time, money, training a particular person, because that would be the analogy for doing fine-tuning or training. So there is a cost. I mean, there kind of seems like some cost. Okay, I need to then come up with all these well-defined tasks and all these well-defined instructions, which the analogy is I need to go invest and spend time and money to build those knowledge graphs. But then the argument is that that's actually going to be is the argument that it's going to be cheaper than investing in doing a large fine-tuning or training a large language model, which I would think, I don't know if it would be cheaper. I mean, I think it could be cheaper, but the other thing is that those knowledge graphs are not just for that large language model. It could be used for many other things too. So it's
many other things, and we are underutilizing knowledge graphs right now. So we've been talking so far today about using knowledge graphs as input to RAGs, but knowledge graphs are really helpful for training in the very first place. They're useful for defining much more interesting loss objectives for training the models in the first place. This is like the PINs, the physics-inspired neural networks, where they have theory-driven criteria for saying whether how well a model is doing at a particular stage in training. There's not been a lot of work with that. I haven't seen any work using knowledge graphs at every step of the process. That might be good as well. So at each step of the process, you could use one part or optimize your use of one part of a knowledge graph. So there's a lot of opportunities there. The other thing is knowledge graphs are cumulative. When you build a knowledge graph, you accumulate knowledge, okay, that you can reuse and share, and it becomes a resource. When we build prompts, it's not clear that they're going to work again in a month or after any updates to the system or adding new documents to the RAGs. So when we can talk, we need a study. I think you're absolutely right that we need more information about the trade-offs with regard to cost for all of these things. So I've been reading about e-science recently, and this is one thing that's becoming a really hot topic for them. To get government funding, you have to ensure that you're using standardized data, that you're producing data that is standardized and can be reused by other teams. Okay, that's total opposite of what we're doing in AI. We're doing ad hoc collections of text corpora with ad hoc hyperparameters, and we're producing something that looks kind of pretty good. But when you go into GitHub and you try to reproduce some of these things, it's really, really difficult. So what kind of an investment is that?
So I'm per this conversation right now, it seems that considering a given task, you want to be able to start with start with something small from a knowledge graph, and then that knowledge graph would be a way of connecting it. It could be from structured data, it could be from unstructured data, can make those connections. The vector database is just another way of storing information for some faster retrieval on semantic similarity. But it's not a vector database versus a knowledge graph. It's like those two. The vector database can go. It's just another way of storing the embeddings from the knowledge graph for fast retrieval.
That's right.
Which is, I think, that's a very important distinction, because I see others, and including myself, that I argue sometimes, like, oh, you think about vector databases for things around text, and then when it comes for like the structured data, like you're not going to take structured data in your relational database and then put it and store that as embeddings. Like,
but you could.
You could,
and there are benefits.
But you already have all that stuff. I mean, for privacy reasons, I think it's updated all the time. Like, again, it's some sort of like bring up the vector database. It's like, do you want to do another ETLing? Maybe you do it, but for the stuff that you want to have, that really important retrieval that drives a lot of the semantics right there.
If the efficiency makes it worthwhile, yes.
So think about this architecture. So you have whatever types of data, structured, unstructured text, relational databases. You have the knowledge graph, which is that semantic layer that connects to your relational databases, can connect to the text, right? The concepts, you can map them to particular things in the text. Now, all of those connections, all of that graph basically can also get stored inside of a vector database. So you can have faster this. And then now now let's talk about the connection from the large language models. So one approach that we see now is that the large language models and the vector databases kind of go together. But I am also seeing one of the things that I'm looking at too is like the large language models can then generate queries that can go directly, like don't even touch the vector database. It can go query directly the knowledge graph.
Of course.
So again, there's different interfaces between the large language models and where the body of context is coming from. And my impression right now of where folks are doing things is that the immediate connection is either to a vector database. People are also generating a SQL query, which we're now seeing evidence that's not very accurate. I mean, you can do it, but it's not very accurate. And the evidence is that if you actually generate it to a knowledge graph, that query over there, it's going to be much more accurate. So that's kind of how I'm seeing this architecture laying out. And then
I agree. Yeah. So this is, again, what we're talking about is the LLM like as an API. So it might be an API to humans, but it might also be an API to a SQL database. It might be an API to a knowledge graph. We're talking about LLM as API, which is cool. But what we're getting from the knowledge graph is what I call adult supervision. Right? We have all of this craziness with hallucinations and gaps and going off on tangents and all of these kinds of things. But when we harness the energy in an LLM and give it the guidance from a knowledge graph, then we're talking about something qualitatively better.
That's another t-shirt quote right there. The knowledge graph is adult supervision. And I think the reason why I'm really smiling about this is because from what we've been talking to people and just and see what's going on is like the three main concerns. If I would look at it, I mean, there's more, but like the three ones that I come all the time is obviously the hallucinations. I think that's the number one, right?
Yep.
The hallucinations, and then that happens that we have this lack of accuracy. And then the second one is around the explainability. So the lack of explainability, right?
Explainability.
It's this black
and there are gaps. So I have in one of my blog posts, I have a long list of issues that people have found with LLMs. We talk a lot about hallucinations, but there's really a huge list of other things. Like LLMs will arbitrarily just skip over stuff that they've been shown. So there are these gaps where unexplainably the correct answer just doesn't show up. Okay? And there are a whole bunch of other issues like this. I want to emphasize that it's not just hallucinations. The hallucinations are shocking, but there are a whole range of other issues like this, which is why we need something like, adult supervision. You gave me this answer. Does it fit? You have these 3 possible answers. Which one is the one that makes the most sense? We can use knowledge graphs for all of these things.
Because the on the explainability, kind of I see this as it's this black box for an explanation. In fact, the explanation itself could possibly even be hallucinated, or it could skip over stuff, have all these gaps. And then a third one that I see is more on the security and privacy, which is like the concern of like, oh, I'm sharing this stuff to the LLM, some private confidential data, and frankly, it's really like a lack of governance. It's like you don't know what's being put into
guardrails.
That. It's the guardrails. So So if I think about the whole how knowledge graphs fit in, is like, hey, if the LLM says something, I should be able to look it up in the knowledge graph and say, oh, does it exist? It does exist there. So okay, I know I'm not hallucinating.
Yes.
And if it doesn't exist, then I know that that it was hallucinated or something, right? So that can help deal with the accuracy. Then the second
there have been some studies where they use knowledge graphs as what I call cognitive guardrails, basically as a filter for outputs. So you can re-rank the LLM outputs based on what you get from a knowledge graph. So that's yet another use of knowledge graphs. Okay, and it turns out that the guardrails, like the Rails language for formulating constraints on outputs, right? To get rid of things that are, privacy related or obscenity related or anything like that. Well, they're in this format. They can be formulated as knowledge graphs as well. So that's knowledge graphs on output. And this is what I was saying before. Is I've seen studies where knowledge graphs are used at each and every step of the training and deployment of LLMs, but I haven't seen anyone use them at all of the steps.
Yeah.
For effective adult supervision.
That's one of the things that we're seeing kind of in the result in the research that we're doing, is that when a result comes in, I can then check it with the knowledge graph and saying, well, it matches what it exists, so therefore it's correct, or it doesn't match, I know it's not correct, or if you figure out it missed some path or whatever, then you can possibly even fix it. You're like, oh, you missed this part.
Yeah. So that's interesting, because that example is the after the fact checking, the filtering on output. But what I was talking about before of using the knowledge graph to determine the loss function is doing the same thing initially, doing initial training of the system. So you bake in more coherence to the LLM. And then we can avoid all these after the fact Band-Aid sorts of things.
So we talked about coherence and cognitive guardrails and some of these different things. What about like, one thing that I don't see enough with LLMs, and I'm curious how much knowledge graphs can help, is around confidence, right? Like sometimes I feel like LLMs are a really good bullshit artist, right? And it's always like 100% confident when it's going to say something. Is there a way to bring more nuance into things, and are knowledge graphs a piece of that?
I think this is what Juan was just talking about. This is, on output, here's your response. Let's rank it based on what we know from our knowledge graph. Is this BS? Is it too vague? Do we have more specific information? Is it just wrong? Right?
So actually modulate the generation based on that information. So maybe this is the most likely word that would come after this by default. But if I actually think about the confidence level based on the actual knowledge, actually that's not the best next word. I should use this other word instead.
Right. And the other thing that's involved there is usually when we're generating the next word, we take the next token. We take the token with the highest probability. Mm-hmm. But I haven't seen anyone stipulate that there's a minimum threshold, right? It's just the best among the options that I have, and they don't have any criterion for saying, well, the only thing I have is junk.
I love that. This really gets me going.
This is why it just generates. It just generates. It's the best option that I have, even if it's horrendous.
Right.
The probability
if
is
it's
1 chance in
under-
16 million, but it's the best.
If it's under a certain threshold, shouldn't the LLM say, "Huh, good question. I
no
have a question
idea.
back
Yes,
for you"?
that's right.
Tell
But
me
I've never
more.
seen that. I've never seen that implemented.
Mhm.
That kind of, what would you call it? Safety net.
Mhm.
That's an interesting.
And depending on the task at hand, you might want to have different thresholds, right? A
that's right.
sales bot that's telling you all about a company's offerings would probably
They can
have a
bullshit
lower
all at
threshold.
once. They can bullshit, right? That's
Yeah,
normal.
but something trying to evaluate a molecule for toxicity should have a pretty high confidence.
I hope
percentage,
so.
right?
And these are getting deployed in medical contexts for clinical applications. I would like a little bit more work on confidence scores than what we see.
That's
Right?
understating
So,
it.
Juan, if you dive in and you look in the training algorithms, you'll see that they have argmax.
Mhm.
Okay, that's all they have. There's no mention of a threshold.
That is
So every
true.
time I see argmax these days, I say, "Uh-oh, red flag. We have to double check this stuff."
Yeah, so you're always the max is not always. That's a good
It
point.
could be maximally crappy, but it's the best we have.
The best is crappy. Therefore, return the crappy because we always want the best.
Yep. And you wonder why it hallucinates.
There we go. So so why it hallucinates because it because it returns the best crap.
Yes. It only has crap, and hey, this is the best crap I have. Take it or leave it. There you go.
It
I'll
can
give
be
you some
gold
more if you
or
want.
It can be gold painted. It doesn't matter, right?
That's right. And all you have to do is put continue as the next command, and we'll give you more of it.
So I think that's the best definition of hallucination. It's the best crap.
Yeah.
That's another T-shirt,
Yep.
right?
There you go. We have a T-shirt factory going here.
We come back to it again and again, Tim. We got to start a T-shirt store.
I know. That's like the running joke now.
Oh man, I got so much stuff to go, but we gotta start kind of wrapping up a little bit here. Okay, so let's go into our AI minute. We've talked a lot about AI, but I want to know from your perspective. You have 1 minute to rant about anything you want on AI. Go.
1 minute. Labels. I have a really hard time with labels. We label, we do labeling. This is something we inherited from, the developing data for machine learning. People rely a lot on labels. All you have to do is label something and we're done. So I have a problem with it because nobody knows what the labels mean. There's no semantics involved. It's just a string of characters, and there's not much we can do about it. We can't validate it. We can't double check it. We can't leverage it for anything else. So this is an overuse of strings because the semantics seems so transparent and so obvious to us as humans that we forget that we have to give more substance to the machines. So that's my pet peeve with a lot of the things that I see going on. And this is why we have, ChatGPT version 2, which is just text and text and text and text and text. Okay, and it made wonderfully bullshitty but smooth sentences, and that's it. How much I got? I can't see the numbers.
You're done. But that was good. This was a really good rant on labels. That was I love that one. All right.
My favorite comment on labels is that a Nobel Prize winner wrote a whole book about labeling. That's how important it is, and how important it is to get right.
So it should always be it's like semantic labeling.
Yeah.
You know what it means.
And it's super fascinating that so much time and energy has gone into something that may ultimately not be as helpful as we want for the next chapter.
Well,
Tim, you are a diplomat. I would say for such trash, millions of dollars spent on trash.
Thank you for the honest no BS, Mike. I almost
no BS
there.
This is why
almost.
That's why Tim is in the C-suite.
Tim's been reading too much LLM output, so he just kind of it flows. But yeah, very much of the labeling data. I stood up a labeling team at LinkedIn and have worked on it for all kinds of things. And the vast majority is just junk data that we pay for.
I'm excited that we live in a nerdy world now where the best way to do a burn on somebody is to compare them to an LLM.
There you go.
All right, we got our lightning round question, so let's kick it off.
Go for it. Let's go.
Number one. So do you think knowledge graphs are going to be much more widely adopted because of all this excitement around generative AI? Or as but as you've said before, like it comes up and now, this is now the one that's going to keep it up?
Oh, I sure as hell hope so. I don't see any other viable alternatives to making LLMs really useful.
All right.
Love it. Second question. Some percentage of companies should actually train their own LLMs. Do you think that percentage is greater than 20%?
Train their own LLMs. So my former boss at Intel Labs, Gadi Singer, has a piece on small-scale LLMs, small-scale LI. So LLMs, small-scale AI. And his take is that what we'll end up building are an array of small ones and fewer foundational models. Right? So if you have a small, medium business that sells, I don't know, motorcycles, you don't need 150 billion parameters to build a solid LLM. So more than 20% are going to make their own.
So yes, yeah. So yes, more than 20, but it's there's a whole nother topic I feel like maybe for another episode around like sort of ensembles of LLMs working together, right?
So I think if you would rephrase it as not LLMs but SLMs, small language models, then probably be more than 20%.
Okay, then we can parse out the terminology later. What you're calling small, what you're calling large.
Yeah,
they're language models. It's really clear that we have to train them for different domains, right? Because each company is going to have its own terminology, its distinctive terminology. Their buyers are going to have their own way of formulating questions. So it's definitely, the API is going to have to be different.
One thing I was talking, actually this week, I was with a customer, we're going through doing some work like this. What came to mind was, is this an opportunity to actually get people within an organization to finally agree on a language? Because these LLMs are trained on a language. Hold on, you're shaking your head, but give me a second. So you train.
No way.
Hold on. So it's trained language. Now people start asking questions, and if you want to have some clarity, like you would expect the large language models, you have a knowledge graph which has the terms, these labeled words that are defined in the knowledge graph. So now when you ask a question, if that question doesn't map directly to the words that we have, the symbols that we have, it doesn't map. But then what you can do is that you can rephrase the original question that a user came in saying, "Oh, do you mean this?" And now the return is going to be the language that's in the knowledge graph. And then after a while, the user is like, "Well, I'm going to start using this terminology that's being told me all the time." And then suddenly, I start changing my language, my behavior.
Yeah, good luck with that. Good luck with changing anyone's behavior. But this is one of the key strengths of LLMs, is the coverage of this linguistic variation. Okay, and this is why we need this human interface.
This is where I think we'll disagree.
I tried to work with standards and writing standards and that kind of thing before, and it's really messy.
No, but thinking about changing human behaviors, we look at Google, for example. Like before Google search you had to know all these complicated Booleans, and then they made it so damn simple that we now do keyword search that's simpler, right? So they changed the behavior of mankind on how to search to keywords. And now And now there's
How are
a
we going to
change of
cure
behavior
everyone?
happening. But now we're changing another behavior to like, oh, I'm now for me to search, it's not keywords. I can actually write questions. But that's
Right.
not how we've been searching for things. So there's a human
That's
behavior
right.
changing right now.
You're
And
absolutely right. You're
so
absolutely
if
right.
these
That's
chatbots are
going to
really going to
entail
take off.
change in behavior. Yes.
So anyway, so
Right.
I
The only thing I was reacting to was kind of having some sort of standardized language and pushing people towards that, and that's not something I think will happen. Quite the contrary. I think the LLMs are helpful for maintaining the diversity.
I think we can
Linguistic
sit down
diversity.
and come up with theories or arguments for both sides. This is interesting. All right, let me go because we still got to go. We got a couple more questions.
Tim's going to tell us to shut up in a minute. Let him go on.
Who's got the next question? Juan, is it you?
Next question. I got that. Okay,
Yeah.
today we talked so much about hallucinations. Do you think 5 years from now we'll look back and say that was silly? We thought that was a big problem and we solved it, or not?
No, I think we'll say it was silly that we did things in such a way that we created hallucinations. So hallucinations are an indicator of a more serious problem. That's what I would say. And 5 years from now, we'll say, oh my goodness, why did we do things in such a stupid way as to generate hallucinations? And I think knowledge graphs, leaving to one side, knowledge graph is a big part of the solution that we're going to find.
I love that. I love the way you flip or reorganize the question there. All right, last question. Are data people going to need to become knowledge graph experts to take full advantage of AI?
Ooh, interesting. Yes. I would say yes. So the data science people that I know have really significant problems all the time in interpreting what the column labels mean in the data sets that they have, because they're very often not documented. Okay, and you have the same label from different teams, and it means different things, right? So when we can standardize the column labels with a knowledge graph, then data science people, I think, will be much happier campers.
So we're going to need more ontologists and taxonomists in this world.
Oh, definitely. Ontologists and knowledge graph people.
All right, Tim, let's wrap it up. Takeaway time. Take us away with your takeaways.
All right. Well, we kicked things off with asking you about the honest no BS on AI and LLMs and KGs, and you said that knowledge graphs are good for reasoning and coherence, and LLMs are good at language. And language and cognition are separate. And although the LLMs appear to be reasoning, do they know what the concepts are? There's an illusion of cognition, and this is one of the main reasons why I think you and many others are advocating for making sure that knowledge graphs are really a core part of the overall architectural picture around AI. And we started to get into architecture conversation, and you really said that, there's like the sandwich model, LLM is input, knowledge graph, LLM is output, and kind of mentioning that we shouldn't mix these things up. We should really keep the separations clear, and that KGs are the semantic layer, and how to create them, is a very interesting question. Even being able to create them from text is an interesting area of research. But in general, you really want to think of the KG as the semantic layer. We started to talk about, what about vector databases? Well, you said that the key question is, what are you putting in it? Usually strings. And that can be useful, but it can also break down in various scenarios. So like wine and cheese are used together, but that doesn't mean they're the same food group. Doctors and nurses are very related as strings, but that doesn't mean that they can be synonyms for each other. And that when you bring knowledge graphs into the picture, then you have the context to distinguish between these very important nuances and these very important things. And how will KGs and vector databases come together? Well, you said that vector databases are kind of like a re-indexing of the information from the knowledge graph. It could be also a SQL database or documents or other types of things, right? And putting it in a format that happens to be performant and useful for this particular use case. And so, knowledge graphs and vector databases are not really apples and apples, right? It's vector databases are a particular technology, a way of storing and retrieving and querying that information that happens to be performant for this particular use case. That information might be coming from your knowledge graph or even part of your knowledge graph. So I thought that was very interesting. Finally, before I hand it over to Juan, what about Retrieval Augmented Generation, or RAGs? You explained that RAGs are, you put in your query, and then in the background, the software is going to the knowledge graph or a database or somewhere, pulling the information that seems relevant, adds it to the prompt being sent to the LLM, and then these context fields are going to be added to the prompt. So when kind of this is a way that we're seeing that's becoming pretty common to be able to access information and use information as part of knowledge graphs and LLMs. And so much more. But Juan, over to you. What are your takeaways?
Oh man, so I love that we went through this whole brainstorming of what a reference architecture can be. And so, first of all, it's like really depends on the task. So we kind of go on through the whole chatbot to answer things about the offerings of your company, right? So if that's the case, you can start. This could be made available in a knowledge graph. It could be coming from a collection of documents that you can use the vector databases as for it to be more efficient. And the LLM, it consumes the info and it produces the response. And a quote here, the LLM is the API for humans. And this source could just be as text or documents, but then it has, if the source is just text or documents, it can have different ways of saying the same things, can have contradictory information. And this is where the knowledge graphs come in, right? Because it provides that accuracy, and that's why it's important to have it from the beginning. And also, great reminder of why are we using RAG here when we start thinking about in this architecture is because we're using these foundational models. So, and it doesn't have all that context. So you really want some sort of drivable AI. So it can go this way or that way. Now, you can also think about what about training or the fine tuning? Well, this requires much more resources, money, people, time. So it may not always be worth it. And effectively, that's why we do RAG. And it does seem like a Band-Aid, but another way of thinking about it, it's like, well, do I have to train somebody to invest time and money to train them to go get a PhD or 30 years of experience? Or can I find a way to define the specific tasks, instructions, and boundaries so I can get somebody off the street to go do that? Different types of investments that can be different, can have different scalability on that. And we talked a lot about what we are underutilizing knowledge graphs. It's not just for RAGs, but they help with training in the first place, devise better loss objectives for models. We're not even using knowledge graphs for every step of the AI training process. And there's most research that needs to be done. And then when you build them, they also become resources that live on and they can grow and evolve. It's not clear that the large language models will work the same way tomorrow as if they did today, because it's a very unpredictable resource. And it provides also this cognitive guardrails, right? So we can actually give some re-ranking of results from the large language models by looking into the knowledge graph. Was this a correct thing? Was it BS? Was it kind of vague? Could it be better? Another great quote, what we're getting from knowledge graphs is adult supervision. Another great quote, hallucinations, returning the best crap. Why? Because the most probable thing that is next may have low probability, but it's still the highest of all the probabilities. So we still actually need more work on that confidence scores. And there's also more issues, not just hallucinations, but it's like gaps, right? It skips over stuff that actually has the right answers. They could have the right answers and so forth. Woof, that was what we discussed. Anything we missed?
Nope. You're hired. Next time I need to give a presentation, I'll just hire you guys.
Well, you can just send them this podcast.
There you go. I will, definitely.
All right. Well, Mike, throw it back to you to wrap us up here quickly. 3 questions. What's your advice? Who should we invite next? And what resources do you follow?
Advice. Chase down the meanings. Don't rely on strings. We really need to make sure that the machine knows what things mean, not just us. So that's the advice. Who should we talk to next? I'll have to get back to you on that one.
How about topics?
Topics?
Yeah.
Topics. Yeah, there are some good topics. I think we need more research into the different ways that we can leverage knowledge graphs. And there's a huge amount of research that I haven't been able to synthesize yet on how we can build knowledge graphs. I think it's clear from the things that I've been reading that there's a growing consensus that knowledge graphs are going to play a very important role. And then the next question is, how do we figure out which graphs to build and how do we do that as efficiently and cheaply as possible, right? And then for resources, archive, and I actually bumped into a journal called the Journal of Biomedical Semantics. Okay, and they're doing some very interesting work. They're publishing some very interesting work on knowledge graphs, which are called ontologies in this domain, and how the traditional approach to ontologies has to grow to make scientific research in zoology and morphology and medicine more effective. This is what I've been reading recently. There's some very interesting stuff there. They point out limitations with, with existing ontologies and directions for growing them.
I have a paper in the Journal of Biomedical Semantics.
You do? Ooh, I have to look at that.
No, it's a mapping between ontologies, oboe and owl. But anyways, that was a previous life of mine.
Right. But it's really interesting to see. It's interesting to see that oboe and those kinds of ontologies are evolving towards becoming knowledge graphs. So I don't think there's much of a distinction anymore between ontologies and knowledge graphs.
Well, Mike, this was a phenomenal conversation. I think there's so much to unpack, and I hope people who are listening, I think they're going to have to listen to this multiple times because there's a lot of very valuable information. Just a reminder, next week we have Kat Greenbrook. She's the author of the upcoming book, The Data Storyteller's Handbook. So that will be a phenomenal conversation because that's a topic that's coming up over and over again, data storytelling. She's actually one of the recommendations from Shane Gibson, who was a previous guest here at Cataloging Cocktails. And with that, Mike, thank you so much for being on the podcast. Thank you so
much. It was such a pleasure. Thank you very much.
Cheers,
Talk to you again soon.
Bye, everybody.